All right, so now we have seen the global offset table. So let us go to the Kali and we'll check where we have to jump. So this is where we have to jump, guys. So we'll see how to work on this. All right. Okay, so let us open the GDB. So we have seen the offset. Okay, so this might not be the direct memory address. So we see if there's a problem, we'll try to work it out. So we'll open up GDB. GDB minus Q and then ED. All right, so that's done. So now disassemble name. So this is where we have to jump to. Right, so okay. All right. Now we are going to run. Uh, Now we are going to go to this location. No, that's our target. No, um, let me try to build that. So we are going to run, and then of course we can do that. Okay, now we have to give the rather than giving A's because there's no point now. Previously we used A's, 4 A's, 4 bytes. So now that's out. So we have to now give the location, right? Of so of course you need 4x's. Yeah, to provide that location. Okay, let me get the location first. Not this, I need this one. Okay, so this is the location, guys. This is the location that I want to go, but remember this is in big Indian, so I have to convert it to little India. So if you do this, okay, so this number that I need. So how should we do this? So 18 should come here, okay, and then should be C0, right? Yeah, C0, and then you find 04. Yes, 04, 04, and then you got 08. Is it good? Yeah, it's very good, no? And then okay, we have to write to the fourth location. So I will do the hard way, not the easy way, and then we have to do an N. So this will not run. We'll check if there's any problem, guys. Yeah, it has segmentation fault, but I do think you have to put a dollar in the front and then quote, and also a quote in the end, and then we'll see what's going to happen. Okay, all right, which is cool. So now there is a segmentation fault, but there is a value here. So what is this value which is written? What do you think? 1b. You need the calculator. Okay, it's hex. 1b is in decimal 27. Okay, what is 27? Yes, any idea? Uh, yeah, so actually, so that's basically calculating all these values, right? All these values that we have to insert. So this is what you are sending. So this addition of all these values, no? So that's what is printed to n. So that is 27. So that is successful, right? That is successful. So now I need to check. So I have written to this memory location, right? Memory location, which is the return of the GOT put function. So let me check the location 0x. So what is the location? So you have to write from this side to this side 08 and 04 and Z018. Oops, you get the value 1b, which is great. So I'm going to now print with a D 27. Perfect. That's fine. That's cool. Okay, I hope that you got this one. So this is the command which you have to write in. So I'm going to take a copy of that and I'm going to put it here. So this is how you access the RAM location using GOT value. So that's how we're going to run it. So now we have your own value, which is the location, and then you do a write, and then you can of course check your value in the location. So this 27 is the collation of those inputted values. Access the return address using this one and you will see the value there. Good. So that part is done. All right. Okay. Now what to do? Now, yes, now we have access to the memory, right? So now we have access to the memory. Now guys, we need to do something interesting. Okay, so we go back to our whiteboard. So now we have the 4-byte. So we haven't yet got the 4 bytes that we created, but we have the address, right? But this address doesn't have anything. So this is like that, the hijacked address. So we have to overwrite our own address. But before that, even though you got the address, what you have there, so there's nothing there. So we have to create address, right? X something and put your shell code there. So now we are going to run a shell code. That's our exploit code. So that's the next cool thing to do. So how do you write a shell code? All right, that's the next problem, guys. Next problem. Okay, so let it hang around here. I don't need this anymore. Now I know the drill. So let me find the shell code, right? So to do this, actually what I have to do is I have to set up a shell and should be up and running in the memory. So that's what I have to do. And to do that, I'm going to write a small code. Okay, I'm going to write a small code. So let me write a small C function for this. And I'm going to name this as egg. So this is called egging. Okay. All right. Okay. So let me start writing the code. So I'm using UniSTD header. And all important, next I'm using something that interesting. Yeah, so this is called a NOP sled. So NOP is no operation. So I might use these NOPs to identify where in the memory my code resides, my my shell code resides, right? So normally you tend to put the 0x90, it's common. And then I need to feed the shell code. That's the code, which I'm going to put later on. So how should I put it now? Yeah, I put one now. So this one, don't really worry. this just comes, right? So you can find this shell codes many places. So I'm just taking one. So you don't need to type it this way. You can obviously find it on somewhere and paste it, but I'm going to write it. X68, X something doesn't work, so we'll see X2F, X2F, and X73. So this should write the code and then convert it, and then you can feed it here. So that part you really don't have to worry. Okay. X2F, X62, and X69, like match69, right? XCE, X89, okay. I'll double check X31, XC0, X31, XT2, X50, X68, X2F, X2F, X73, X68, X68, X2F, X62, X69, X69, XC, X69. Oh, that's fine. I have a bit more. This is not the end of the shell. You can continue like this. XE3, all hexacodes. X52, X54, X52, X54, X89, XE1. So you should be able to write codes like this from your head. All right, it's a lot of fun. Let's see. So find the way how to write the codes from your head, the shell codes. All right. That's not pun intended, okay? Right, XE3, X52, X54, X89, XE1, XB0, XACD, and X80. All right, cool. That's done. So let me run my, oops, in main. Okay, I don't need anything there. Okay, now I'm going to get the shell code very big. And then I'm using the memset function. Oops, and I'm going to get the shell and get the knobs. I'll just define here. Alright, so should be capital. Oops. And 512. Okay, that's done. Then I'm doing the memory copy. Okay, and then you will get the shell. Okay, this is my array. Okay, 512 string length of the shell code. And shell code string length shell code. So basically I'm copying everything to this value. Okay, then this is the important part. So I'm going to set up an environment variable, oops, called egg, of course, egg2. So because I created egg earlier, and I'm going to add the shell, and I'm going to put one here, and then I'm going to put the environment variable, which is the shell. That's it, and I'm going to do it in the bash. Bash. Okay, good. Return 0. Okay, that's all fine. Let me check the code is correct. Okay, fine. Okay, now I have the egg code also. Let me compile this. Okay. Anything missing here? Nope, seems to be okay. GCC. These codes, I don't really have to worry too much. And then the egg. Okay, warnings, 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 no errors. I have the egg. I'm going to run the egg. All right. Okay, cool. No? I have my egg. What is this? Ah, that's a shellcode. All right. That's a shellcode. Now what I'm going to do? Now I want to get the address of the shellcode because I might need it to do my activities. For that, so I have a up and running shellcode, guys. So what I'm going to do is I'm going to write another small function, quick function, to find the egg value or the egg location. Don't worry, that's not going to be a big function. I will write egg finder function .c egg finder.c. Okay, so hash include unistd.h. Okay, that's done. In main void. Okay, then I'm going to printf print egg is here. Egg is here, and I have to format this. Formats, all formats. All right. Okay, and get the location. All right, and the first value. Small space here. That will do, and then get env. Yeah, and then the egg2 because I named it as egg2. That will do the trick. Oh, I see. Return 0 because it's in the return. Okay, that would do. And GCC, sorry, egg finder, that will do the trick. Okay, warnings. There are some errors. What is it? Okay. Badly. Come on here. One command missing, and also this is also missing. Okay. I think that will do the trick. Yes. Egg finder. So let's see. Yeah. So that's the location. That's the starting address. All right. So now I need the exact address of this variable, so where I'll be able to all right, I'll be able to write it here, and using this function I'll be able to write it there. So that's my concept. So let's find the real location. Okay, that's my next challenge. So my shell code is there. Now to get the, so hope it's clear to all of you. So now if I go back to my whiteboard, now I need to find out the location of the shell. I have now created the shell code. Everything is fine. Now to get the location of the shell code and load that one in here, right? Then it does the trick. So let us do that now. That's the cool part, right? That's the cool part. I don't know whether it's cool or not. We'll see, right? We'll see. Okay, so to the curly box, right? Now to the good part. Now to the fun part. GDB Q EV. Okay, now how to do this one. Now, how to find, there are so many ways of finding this location. Even though I get that address, I don't think this is really valuable. I will anyway copy this egg finder to my note. Okay, this is the egg finder shell location. But I need to find the exact location. Without that, I can't do much. So guys, now what I can do, now I know the shell is running. Let me do this. Yes, so you need to look at the stack. So everything is there's the stack, right? So I need to go to the stack, start of the stack. Let me do this in this way. X, right? ESP. So all important ESP. Oh, I have to run this, no? Okay, what I'll do is I'll do a break. I'm not going to run anything serious. Okay, now I'm in the ESP. So now I need to check the stack, guys. So x dash x print also is fine, but I'll do x ESP. Okay, so I see the start of the stack. Let me check 10 values. All right, I see the stack. Let me see 1000 values. Okay, I'm seeing 1000 values. I don't see what's expecting. I'm expecting. So what I'm expecting, guys? I am expecting the NOP. What is the NOP? Okay, all right. I've seen the NOP. Yes, see, this is what I filled with my egg function. NOPs, the NOP sled. So a lot of 90s. Now, let me check. All right, so this is where, yeah. This is where 90s going away. Yeah, so this is the place where I'm a bit interested. Okay, this is the place I'm a bit interested. So why I'm interested in there? Why I'm interested? Because this is where shellcode starts, somewhere down here. So let me check this location. So this is where NOPs are ending. So I'm going to make a note, end of NOPs led. Okay, so this value is important, guys. This value is important. Okay. All right. Now, what to do? Okay, now what I'm going to do, I'm going to get this value. Okay, I'm going to do a XX and check this value. All right, so the cool thing is, see, I see a, I don't need the D. So I see the NOPs, and then I will check 10 values from here. Yeah, so see, so here you will see the instructions, right? So this is where probably the shellcode starts. So I can probably do when I, yes. So see, the NOPs are there, no operations, and see there's a EAX. So that's where the shellcode start. Good. So let me come back quickly. All right, let's go. here. Now I have the value, so this is the value that I have to fiddle with. I'm going to copy this one. So this is my point of entry for the shell code, right? So let's me, okay, I have already copied it, no? All right, so P for the sled, and this will be the entry point, entry for the shell code. All right, now I need to do the crazy bit, which is I have to build up the run command again. All right, so this is the real fun starts. So I'm going to get my old run, all right, and do a bit of a modification, guys. That's my run, that's my run, that's my run. Okay, it's not here, so I'm going to take it from here. This is the run which I used earlier. I'm going to get this. I'm going to do a bit of a modification to this. So mind with me. So I'm going to write a small Python script here. So you will learn that method also, Python -c, and so this will be useful later on. So we'll discuss about it at that time. Print. Now it's same stuff. All right. And then let's goes away. Is that all? I hope so. Okay, double check, everything is fine. Python -c print. Okay, so my location of ROT, RGOT, and then here a dash if you want to, and then XXXXN. Yeah, but I don't like this anymore. So what I'm going to do, oops, sorry. I'm going to do put the fourth location, and then that will do it. Oops, some error. I don't like errors. Yeah. In the beginning, print. Okay, that would do. All right. Something is missing here. This is where I have to close this. All right, and a bracket, and then a dash. You don't need anything here. Okay, let me check now. Oops, again, the same issue. All right. Sorry, just give me a second, guys. I will come back. Okay, all fine. So, options here. So this is the command, right? So when I run this, it tries to, I'm in the breakpoint, I don't need less, continue. Okay, so 5 is written to the location. It's all good. So this is the previous one. This is the GOT's Putsha location. So I am writing 5, right? So I'm writing now few characters here. So that's what I'm writing. Okay, now we'll try to modify this. Now we know the address, right? We know the address of the shell, this one. So we need this one here represented, right? We don't need 5, right? So this is our challenge now. How to do this? So to do this now, you need the calculator, right? So let's try to build this one. Okay, let's try to build this one. Okay, so now what you have here is file. Okay, so let me get the cal. Okay, so from hex, what you need, okay, we'll get that value also. It's easier that way. We'll keep it like this, and we'll, oops, sorry. All right, now it's fine. So what we need is, actually we'll break it to two. We'll first get this part, FDF0, right? For it, what we see, FDF0. Okay, so I need the FDF0 printed here. So I'll type FDF0, and that's what I'm having here. What I need is that, right? So what I'm having is minus 5. So I'm going to reduce that and check what you need. FDEB. So that's what is missing. So in decimal, I'm missing 65,003. So that what I'm going to add to my uh, memory in the end. So I'm going to put 65,003. Let's see. So the run command. So now it's easier for me to handle it this way. So this is where I have to input this. So I'm going to input 65,003 with a U. All right. Let me copy this one as well, just in case if I need it again. Okay. So I'm creating the shell code address. Make it simple. All right. So now what I'm going to do, I'm going to run this. Yes, and then continue. Okay. So you get FDF0. Am I on right track? Yes, I'm on right track. FDF0. This part is yet not completed. Don't worry, we'll come to that. All right, cool. That's cool. So that is created. Now I'm going to add the second part. When I want to add the second part, I need to add the. So this is, remember, this part is the first 4 bytes. So now we have to create the second 4 bytes, which comes next as it is linear begin here. So I'm going to add another byte. All right, and I probably can do the same thing copied. Edit, copy, yes. Edit, paste. Badly. Copy this one. Select, copy, paste, and I need this as well. And now see, that's a small thing. When you do this, now you're moving 2 bytes away, right? So you basically have to move 2 bytes, meaning this should be 1A, because I'll tell you how it's going to happen. Now this is 18. That's actually the last byte. It should be 840Z018, right? So that's the location, and go 2 bytes after, right? So that should be added to this location, 18 plus 2. So if you go to 18 in hex, right? In hex 18, convert to 24 plus 2, and then convert back to hex. That's 1. So because of that, this should be 1A. So this should be 1A, and rest should be same. All right, and yeah. So that ends the print statement. Okay, so I might need a bit of screen estate. All right, all fine. 65,003 and U and 4 and okay. So now I need to have another write up. I'll do another 4 and $n. Okay, all right. Run this. Continue this. Oops. Now what had happened? Nothing here, but there's a small issue. FDF5, right? Previously I got it right, FDF0. Now FDF5. I'll tell you the reason for that. So 5 was added. Let me clear. So I'm going to copy this one as well. We might need this later. Copy. Did I miss one? Yeah, so I missed the $. Okay, that's fine. So now what's happening, because I've added another 5 bytes, so I don't need, I might not need this. Okay, I'll reduce. Oops, sorry. Yeah, that's fine. So I'll put 5, remove 5, so that is 4, 2,998, is it? Yeah, let me check now. Continue. FDF0. All good, FDF0. That's done. Right, so those 4 bytes are correctly done. Right, now I need to fill the first 4 bytes 0, 0. So what I need there is what I need there, BFFF, right? So B4Fs. Okay, I'll run this again just to double check. Everything seems to be fine. So I might need to add whatever the value here, right? Yeah. So let me start with a random value, a big value, 40,000. 40,000 U. Yes, that will do the trick. All right, something is missing. It's not getting updated. What's the problem? Okay, again, this one is still FDEF. Should be FDF0. What's the issue? Let me check. Let me remove this for a moment. All right, I'm missing. Yeah, I'm missing this value here. That's a bad mistake. All right, I'll check. Oh, what happened? All right, they renewed everything. Oh, let me check again. This is fine. $4, so $4 Okay, let me check with this. Okay. Oops, no, it's fine. Alright, FDEF. FDEF, yeah. Sorry, it's still FDF 0. A small change has to be done, it seems. Let me check now. Let me check. So FDEF is what is there, but what I need is FDF0. So something is missing, no? So let me get the calculator. First, I'll try to set up that FDEF minus FDF0. FDF0. Okay, in decimal. Okay, it's a 1. Oh, there's a difference of a 1. So let me put it 99 or 97. So I'll put 97 first. And run this. Continue. No. So this should be 99. Good. So I got my FDF0. That's fine. Now I need to work on BFFF. So BD59. So let me check now with hex. So what I have here is what I need is BFFF, BFFF minus what I have is BD59, BD59. Something very lazy. Okay, guys. So there are much better ways, right? So, but we'll do the easiest way first. Okay, what is that? So we'll get the decimal of it. 678. Okay, I'm not going directly at 678, guys. So it's somewhere here, no? So I'm going to put 677 because if I do 678, it will load the address, it will go to the shellcode, it will execute the shellcode. So I don't want that to happen directly. Oh, that's really cool. So now please check. We are one step away from getting our F. All right. So this is where we are heading for the last two hours, guys. Okay, we need this one. So what I need is another one. Okay, now see, I'll clear the screen. All right, now to the fun part. Now, if I do this, it will create, I really should create that address, shellcode's address, starting address, all right, which is this one, BFFFFDF0. And what should happen if it does that? It should automatically run the shellcode. Let's see. Let's see. Continue. Oops. All right, now it's fine. Now there's another error. FE07. What happened? What happened? Don't worry. All right, something happened to FE07. Don't worry. We'll try to correct it. Am I doing a mistake? I'm not sure, but we'll see. FE07. Oh, sorry. FE07 minus. Did I do a mistake? FDF0, FDF0, 17 is missing. Okay, that's 23. Okay, oops, 23. Oh, not sure. Let's see. 23 plus 64,000. This doesn't work. I have to go back and check and come. 65,020. Okay. Let's see, guys. Oops. Really bad. So let me double check and come. All right. So one of the issues that I had was I mistakenly had a small there was a small issue in the shell code, so I had to rerun it. So now it's fine. Yeah, so my shell code is proper now, so it's running. So then I'll go to GDB. GDB minus Q. Anyway, all right. So that's there, and I'm going to paste my. Oops. Sorry. So I will copy it from here. So this is my final command. Okay, and I'm going to run this now. Edit, paste. All right, now we see what happens. All right, so finally, as you can see, it goes to the prompt. So shell is executed, right? So you can see a shell would be running, right, on my behalf. So that I'm logged into the particular shell. So basically I've exploited I've exploited the code, right? So now what you can do, so you can basically do all the commands, and that is there. So now we'll try to do the exploit from the command line. So this is in GDB, right? Okay, so I'll use the same code. So this is the function program, and I'm going to paste this. Oops. Okay, I'm going to copy this again. Same is the same command, no difference. Okay, now see what's going to happen. So finally, to wrap up, so what's happening is you are going to go to this location and I'm going to rewrite the address, and this particular address, so this particular address contains the shellcode. So we are going to execute the shellcode. So whatever it does from the shellcode, whether it's getting a shell or whether it's doing a remote execution, so whatsoever can be done quite easily. All right. So now, okay. So what's happening? Okay. We check the environment variable. All right. And then and then we will run the code. Oops. So it should be able, yeah, so fine, you get the shell. So if I do ls and get files and who am I, you can see the root user. Alright guys, so this is what you are supposed to do. So come up to this point, and then in the next session I'll give you and I'll do some interesting exercises. Alright, thank you.